Alright, this video is going to cover Module 5, Homework 4, which is factoring special cases, as factoring by special product. So the first question asks us to write the term as a square. So we want to rewrite 9a squared as something squared. So something times itself to give us 9a squared. So I know 3 times 3 will give us 9. 3 squared will give us 9. And a times a, so a squared will give us that a squared. So that way 3a times 3a will give us 9a squared. Same concept for the next one. This time we're going to write the term as a cube. So what times what times what will give us 64y to the 6th. So I know 4 times 4 times 4, so 4 cubed would give us 64. And I know y squared times y squared times y squared will give us y to the 6th. Another way to think about it is y squared cubed. Remember, in this case, we're going to multiply our exponents. So 2 times 3 would give us that 6. So 4y squared times 4y squared times 4y squared will give us that 64y to the 6th that we're looking for. All right, next example says factor, just like we've been doing. 16a squared minus 8a plus 1. So notice our first step in factoring is GCF. There's nothing that all three terms have in common. So no GCF. So we are looking for no GCF. So our A value is 16, just like we've been doing. B value is -8. C is +1. So we are looking for two numbers to multiply together to give us A times C. So 16 times 1. And the same two numbers to be added together to give us -8, which is B. So I'm thinking -4 times -4 is +16, and -4 plus -4 will give us that -8. So we are looking for, so we're going to use those two numbers in our blanks to split up that -8a. So we have 16a squared. Instead of that -8a, we're going to use the numbers in our blanks. So -4a plus 1. We now have 4 terms we can factor by grouping. So grouping the first two and grouping the last two. So looking at our first two terms, we have 16a squared minus 4a. So our GCF there should be 4a. So factoring out that 4a, we are left over with 4a minus 1. Looking at our next two terms, -4a plus 1. There's really nothing in common, but I know I want +4a minus 1 to be left over. So I'm going to factor out a -1 as my GCF. So factoring out that -1, we are left over with +4a minus 1. I know we did something right because they both have 4a minus 1 in common, so that will be one factor. Taking out that 4a minus 1, we are left over with 4a minus 1 again. So we have 4a minus 1 times 4a minus 1, which we can write more efficiently as 4a minus 1 squared, and that will be our final answer. Same thing for the next example, factoring 4y squared x squared plus 12y x squared plus 9x squared. So looking at all these three terms, our first step in factoring is GCF. I notice they all have an x squared in common. So let's go ahead and factor or divide out that x squared from all three terms. So that way those cancel, those cancel, those cancel. So taking out that x squared out front, we're left over with 4y squared plus 12y plus 9. So now we're worried about factoring 4y squared plus 12y plus 9. So we know our A value is 4, our B value is 12, and our C value is 9. We are looking for two numbers that will multiply together to give us A times C, which is 4 times 9, which is 36. And the same two numbers to be added together to give us B, which is going to be 12. So I'm thinking 6 times 6 is 36, and 6 plus 6 will give us that 12 that we're looking for. So we have that x squared out front. We have 4y squared. We're going to split up the 12y using the numbers in our blanks. So plus 6y plus 6y plus 9. We now have 4 terms. We can now factor by grouping. So group the first 2 terms together, group the last 2 terms together. So this x squared is still just hanging out front, bringing it down so you don't forget it. But it's already done, so just to kind of ignore it for a second. So looking at our first 2 terms, 4y squared plus 6y, I notice they both have a 2y in common. So let's factor out that 2y. And we have 2y plus 3 left over. Looking at our last 2 terms, 6y plus 9, GCF, they both have a 3 in common. So factoring out that 3, we're left over with 2y plus 3. So we know we did something right because we wanted 2y plus 3 to be in common for both of them, which they are. So again, this x squared is still just hanging out front. They both have 2y plus 3 in common, so we're going to factor that out. So taking out that 2y plus 3, we are left over with 2y plus 3. So if you notice, just like the previous problem, this x squared is hanging out front. We have 2y plus 3 times 2y plus 3, which is 2y plus 3 squared. So that's our final answer, x squared times 2x plus 3 squared. Next page. So factoring, 9x squared minus 42xy plus 49y squared. Looking at all these 3 terms, I don't see anything they have in common, so no GCF. So we are going to look for A is 9, B is negative 42, same thing like we've been doing this whole time. C is 49. So 2 numbers that will multiply together to give us A times C. So 9 times 49, which is 441. And the same 2 numbers to add together to give me negative 42, which is our B value. So I'm thinking negative 21 times negative 21 is positive 441. And negative 21 plus negative 21 will give us that negative 42 that we're looking for. So we have 9x squared. Instead of negative 42xy, we're going to split it up using the numbers in our blanks. So negative 21xy minus 21xy plus 49y squared. We now have 4 terms. We can now factor by grouping. So group the first 2 terms together and group the last 2 terms together. Looking at our first 2 terms, 9x squared minus 21xy. I notice they both have a 3x in common. So we're going to factor that out from both terms. And we are left over with 3x minus 7y. Looking at our next 2 terms, negative 21xy plus 49y squared. Remember, I want positive 3x minus 7y to be left over. So let's factor out a negative 7y from both terms. They both have a negative 7y in common. Dividing those out, factoring those out, we are left over with positive 3x minus 7y. So if you notice, we know we did something right because they both have 3x minus 7y in common, so that will be one factor. Taking out that factor of 3x minus 7y, we're left over with another 3x minus 7y. So 3x minus 7y times 3x minus 7y, we can rewrite as 3x minus 7y squared. Remember, this is about special cases, so that's why they're all squared thus far. Okay, so next example, factoring x squared minus 9. So our first step in factoring is GCF. There's nothing that x squared and negative 9 have in common, so no GCF. We want to factor this just like we've been doing our other factors. Remember, our standard form is ax squared plus bx plus c. So I want to try to find out what a, b, and c are. So I want to put this in standard form. I see that there's 1x squared. There's no x term, so plus 0x minus 9. So our a value is 1, b is 0, and c is negative 9. We are looking for two numbers that will multiply together to give us a times c, which is -9. And the same two numbers that will add up together to give us 0, which is b. So I'm thinking +3 times -3. Oops. So +3 times -3 is -9. 3 plus -3 will give us 0. So exactly the same thing like we've been doing. So we have x squared plus 0x minus 9. Instead of that 0x, we can split it up and say x squared plus 3x minus 3x. Remember, 3x minus 3x is still 0x minus 9. We now have 4 terms. We can now factor by grouping. So group the first 2 terms, group the last 2 terms. Looking at the first 2 terms, x squared plus 3x. They both have an x in common. Factoring out that x, we're left over with x plus 3. Looking at our last 2 terms, -3x minus 9, our GCF should be -3. Factoring out that -3, we are left over with x plus 3. We know we did something right because they are both x plus 3. They have that in common, so that'll be our GCF. Factoring out that x plus 3, we are left over with x minus 3, so that will be our other factor. So x plus 3 is a factor, x minus 3 is a factor. This will give us our final answer. X plus 3 times x minus 3 will multiply out to give us x squared minus 9. So going back, remember we had a shortcut. When a was 1, which it is in this case, we can just write out our factors. So when our variable is x, plus 3 goes in one blank, and minus 3 goes in our other blank. So if you notice, these look similar or look different too because our b value is 0. So if you notice, I have x squared minus 9. X squared is a perfect square, going back to those problems we did in the very beginning. So it's x times x. It's the difference. So one's positive, one's going to be negative, and 9 is also a perfect square, so 3 times 3. So this is going to be a difference of perfect squares. So there's a little shortcut for these. Remember, we know x squared is x times x. There's a difference. We have a subtraction sign, so we know they're going to have different signs. And 9 is 3 times 3. So let's use that little shortcut we just found to do our next example. So it asks us to factor 144c squared minus 100. So 144c squared minus 100. We need to look for a GCF. Which I'm thinking is going to be 4. So our GCF of 4. So taking out a 4 from both terms, we are left over with 36c squared minus 25. So now trying to factor 36c squared minus 25. If you notice, this is another difference of perfect squares. Difference means subtracting. We are subtracting 2 perfect squares. So 4 is just our GCF, it's just hanging out front. Let's use that little shortcut we came up with last time. So 36c squared is a perfect square. We know it's 6c times 6c. There's difference, so we have different signs. One's positive, one's negative. 25 is also a perfect square. 5 times 5. So this is going to be our final answer. 4 times 6c plus 5 times 6c minus 5. Multiply all those back together, we get back to our original problem. Next example, same thing. 80x squared y minus 5y. So first thing is GCF. What do they all have in common? I notice that they all have a 5y in common. So that'll be our GCF of 5y. So let's factor or divide out a 5y from both terms. Dividing out a 5y, 18 divided by 5 should give us 16. X squared, y divided by y will cancel those out. Minus 5y divided by 5y should give us 1. So 5y is our GCF, that's still just hanging out front. And we're left over with 16x squared minus 1. Again, a difference. We are subtracting two perfect squares, so a difference of perfect squares. So we know we can use our little shortcut. So 16x squared we know is 4x times 4x. There is a difference, so we know one's positive, one's going to be negative, and 1 is 1 times 1. This will leave us with our final answer of 5y times 4x plus 1 times 4x minus 1. Multiply all those back together to give us back to our original problem. All right, so last page for this notes section. This one asks us to factor x cubed plus 8. So this one looks similar to our difference of perfect squares. This time I know we're adding, so it's not a difference, it's a sum. But this time I have x cubed and I have 8. So this time instead of being perfect squares, they are perfect cubes. So if you notice, we have a sum of cubes. So hey, right underneath it, we have a formula for sum of cubes. We have a formula for sum of cubes. So I need to rewrite this as something cubed plus something cubed. Once I know that, I can see what a and b are, and then we can just plug a and b into our formula. So just like those first couple problems we did. So I need something cubed plus something cubed. So I know x cubed is x times x times x. So that's x cubed. And then 8 is 2 times 2 times 2. So 2 cubed. So that will tell me my a value is x, my b value is 2. So wherever I see an a in the formula, I'm going to plug in x. Wherever I see a b in the formula, I'm going to plug in 2. So we have a, which is x, plus b, which is 2, times a squared, so that'll leave us with x squared, minus a times b, so x times 2, plus b squared, which is 2 squared. So the formula already gives it to us in factored form. These are always primes, so they cannot be broken down any further. But the only thing is, let's kind of clean it up a little bit. So we have x plus 2 times x squared minus x times 2 we can rewrite as 2x plus 2 squared we can rewrite as 4. So just kind of simplifying it a little bit. So x plus 2 times x squared minus 2x plus 4 is our final answer. Same thing for the next one. This one is x cubed minus 125. So this time we have that subtraction sign again. So we know it's going to be a difference. And I notice these are also perfect cubes. So I know I need to rewrite it as perfect cubes just like the previous problem. I'm already giving you the answer here. So I know x times x times x will give us x cubed. It's a difference, so we are subtracting. 125 is 5 times 5 times 5, so 5 cubed. So just like the sum of cubes problem, we have a difference of cubes formula given to us that we can use to come up with this answer. So this will tell me that our a value is going to be x and our b value is going to be 5. So I'm just going to plug in wherever I see an a, I'm going to put x. Wherever I see a b, I'm going to put 5. So we have x minus 5 times x squared plus x times 5 plus 5 squared. And then like the previous problem, just simplifying it a little bit, we have x minus 5 times x squared. X times 5 we can rewrite neater as 5x. Plus 5 squared will give us 25. So x minus 5 times x squared plus 5x plus 25 will give us our final answer. So last example for this note section, factoring 64y cubed minus x cubed y cubed. So our first step in factoring is GCF. I notice they both have a y cubed in common, so let's go ahead and factor or divide out that y cubed from both terms. Cancel, cancel. So y cubed's coming out front. We're left over with 64 minus x cubed. So I notice they are subtracting, so it's going to be a difference of two perfect cubes numbers, so difference of cubes. So I can rewrite this, we'll come back with the x cubed in a minute. As 64 is 4 times 4 times 4, so 4 cubed, minus x times x times x is x cubed. So I know this is the a cubed minus b cubed formula. So just writing the formula down here so it's easier for me to transfer it. So a cubed minus b cubed is a minus b times a squared plus ab plus b squared. So now I know wherever I see an a, I'm going to plug in 4. Wherever I see a b, I'm going to plug in x. So we're left over with 4 minus x times 4 squared minus 4 times x plus x squared. Just like the previous problem, just kind of simplifying it just a little bit. We have 4 minus x times 4 squared. 4 times 4 is 16 minus 4x plus x squared. And that will leave us with our final answer. 4 minus x times 16 minus 4x plus x squared. This cannot be simplified. Given in that formula, it can never be simplified. So that's our final answer. So that is Module 5, Homework 4 notes.